From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you will know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an off-site QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But, as we've talked about on the show multiple times, that's not always as easy as we want it to be. Because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. Love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry.
Okay, so sealed classes. You've probably seen the word sealed classes or just the word sealed in general, tossed around in the community in one form or another. You'll see a lot of tweets out there lately about how everybody loves sealed classes. They're the best thing. But if you're not familiar with them, they can be kind of confusing at first. So what I hope to do today is dispel some of the confusion around sealed classes and maybe give you a couple of examples when you might use them and kind of juxtapose them against some existing types of utilities that we might be used to using in Kotlin or other languages. Now, let's really just talk about what a sealed class looks like. And as usual, we have the disclaimer here that it's kind of difficult to explain code over a podcast, but I'm going to do the best that I can. So if we have a sealed class is basically defined by using the word sealed, and that's SEALED, sealed, space class, and then space the name of your class that you would have. Now, a sealed class, when we define it this way, basically let's call it sealed class view state. And it doesn't have open curly braces or closed curly braces, though you can have those, and I will talk about that in a moment. But we'll just say it's just very simple. It's a small one-line sealed class view state. And that's just view state is a word that I'm giving it, and I'll tell you why in a moment. Now, a sealed class is used for representing a restricted class hierarchy, and that's directly from the Kotlin documentation. And I'm using these words from the documentation because when you look it up later and you're reviewing it, I want these words to kind of come back into your memory here. So again, sealed classes are used for representing restricted class hierarchies. Now, what that means is a value. So you could have a class that extends that sealed class. It's going to be one of these restricted types, and it can be from any one of those that are extending view state in our case, but it can't be of any other weird type or anything like that nature. So let's talk about the code for a second of how that looks. So again, we have a single line of code in our IDE, and that's sealed class view state. And the reason why I'm calling it view state here is I would like to represent have like a data class that says, hey, this is the initial state of my screen. And perhaps I have some type of presenter or some type of class that kind of drives my view, right? and I'm going to give it a data class. I'm going to deliver that to my view, and then my view is basically going to implement a when, basically an implementation of a when expression, and I will then be able to perform, hey, is this type going to be of this type, or is it going to be X or Y or Z? And then based upon each one of those types, which again we'll explain, I would like to update the screen or render something differently here. So this is a very rudimentary example, but it's one that you'll see out there a lot actually in the MVI, model view intent. And I'm kind of modeling this very loosely, so don't hold me to the exact pattern, but this is just to kind of help get the thought process across. So if you're not familiar with MVI, with model view intent pattern, there's a fantastic course on caster.io taught by Android GDE Etienne Caron. Again, that's at caster.io. He teaches how to set your application up, how to build an application with MVI, and he gets into depth with these sealed classes. So after you've learned about the sealed classes and you're interested in kind of seeing it in action of what it looks like, definitely go check out Etienne's course. You'll kind of really get your head wrapped around a lot of the sealed classes and see a lot of the cool stuff that you didn't know that you could do. So let's rewind here. We've declared our sealed class. It's called sealed class view state. I know that for me, every time I load a view, I'm going to have an initial state, and that's going to have some data with it. Perhaps I'm just showing a customer on the screen and I need their first name and their last name. So what I'm going to do is I'm going to create a data class. Now here's a couple of things we have to think about with sealed classes. The word sealed is actually a modifier before, the word class. And of course it can have subclasses because we're starting to lock it down. It's a restricted class hierarchy. Now, one of the restrictions that we have here with sealed classes is that sealed classes can have subclasses. That's basically when they become very useful because we're creating that restricted class hierarchy by saying, hey, you have to be of type view state. But here's the kicker. All of them must be declared in the same file as the sealed class itself. So if you've created sealed class view state, in that same file, you're going to need to write this code that we're about to explain here. So on the next line down, what you might do is say data class, and then it would be initial state, and then it'll have two vowels in there. That would be first name and last name. And then after you close out that data class with the closing parenthesis, you do colon, and then view state, open, close parentheses. And basically that says, hey, this initial state data class is actually of a class hierarchy from view state. So basically that initial state is a view state. So what we can use this for is now inside of our view, I may decide to, if I'm using RX or some other type of technology to drive the view, I can actually just deliver inside of a method said, hey, you're going to take a view state. I could give you any number of them, and then you need to determine what to do view. And inside of that view, inside of that method takes one parameter inside of my view, and the parameter is, view state, and its type is view state. Inside of there, I can put a when expression. I say, when is initial state, then I can, do the arrow and perform some different, update the view, do whatever I need to do at that point. So now we've kind of got this very simple here. We've got a sealed class that it's called view state. We have a data class with a couple of values in it with the first and last name. It extends perhaps view state as well because it's, of course, a sealed class. And then from there, I might have another class called updated state. And this one would be perhaps anytime I updated the first or last name. It could be whatever. Let's just say updated first name state. Let's just keep it real simple. And also data class, updated first name state. It would take in a val of the first name, of course a string. We'd close it out. And again, we just extend the view state class. Again, that has to be declared in the same file as the sealed class view state. Again, that's just kind of a rule. Now, remember how we're kind of putting these in their own separate lines? That's okay to do. Now, prior to Kotlin 1.1, the rules were even more strict than just in the same file. These subclasses had to be nested inside the declaration of that sealed class. So you could have, and you still can, go to sealed class view state, and then you do an open curly brace, and then you could put all of your declarations kind of inside that sealed class. A lot of people still like to do that, and because it kind of says, hey, here's this sealed class and kind of here's its members. Here's the subtypes that it's going to provide. So it's very nice that you can kind of nest it out that way. It's not required. If you want to put it on a separate line, you can. You just need to make sure that you're on Kotlin 1.1 or above. Okay, so you have another implementation, which is the updated first name state, and it just has that updated first name. Now you might use that, and it actually may have another value in there, such as like color. And that would be the color that you would change the first name to show that it was updated on the screen for whatever reason. This is, again, a very contrived example. But if we were then to do something and we needed to deliver that result to the view, we could deliver it to the view saying, hey, here's the updated first name. And then in our when expression, we'd say, hey, if this is the updated first name state instance, well, now I know I need to go update the first name. I'm just going to update the first name, and then I'm going to set perhaps the text views, text color to whatever the color is, maybe red or purple, whatever. So what you can continually do is you can have, keep implementing, there's no limit here to the number of, if you want 5, 10, 15, 20, whatever, subtypes from view state, you can do that. Now you can also, you're not limited to perhaps just data classes either. If you want to use the object, which is very common, you can use object as well. And again, that's just going to be object, and you can just call it foobar here, and it would extend view state. And that would perhaps be some type of marker class. You could say, hey, this thing happened. So on the view, update it, perhaps something time was up, change the back, and it's, that could be foobar was emitted, and on your view, you just need to change the background color of the view or whatever. So again, super contrived example, but just saying that all these classes are all extending view state. It could be an object. You can actually also have a class in there too. So just a typical class. So you could have a class that has members inside of it and so forth. Now here's a cool thing that you can also do too. Let's say that you have perhaps you've created a class that's part of your sealed class. It's a part of the type hierarchy that's part of the sealed class. So we'll call this customer data view state. And of course, it extends view state. It's in the same file as the sealed class viewed state. But however, this is just a regular class. And this time we have perhaps a few properties. We have first name and last name and date of birth and a bunch of other customer properties. And perhaps at this point in time, I know that I would maybe even want to use this elsewhere or extend it for whatever given reason. You can actually do that with a sealed class. Now, you'd have to mark that class as open. And now, the nice thing about this, so it says open class customer data view state. It's going to implement view state, of course. And then I have my class declaration. Now, actually, in another file, this is a nice feature here. I can actually extend not the sealed class. I can't extend the sealed class, but I can extend customer data view state. So I may create another class in another file called modified state, and it extends customer data view state. And then I can actually add my own methods inside of that modified state. I have access to all the member properties. So first name, last name, date of birth, all that kind of stuff. And so I can use those outside of the main class itself, actually outside of the sealed class file itself. Now, one also important thing to mention here is that the sealed class is abstract by itself and it cannot be instantiated. So if you try to instantiate view state by just saying view state, open, close, parentheses, anywhere in your application, you're immediately going to see a red squiggly. It's not going to compile. It's because the sealed class is abstract by itself. Furthermore, sealed classes are not allowed to have non-private constructors. So all of their constructors are private by default. So again, to recap there, if you do need to subclass one of the sealed classes, one of its indirect inheritors, it can be placed anywhere. It doesn't necessarily have to be placed in the same file. And the real power of when the sealed class comes into play is the readability of the code. And so I'll have, for example, use the view definition again. This view is going to allow me to drive it from a sealed class called view state. And it would take that as a parameter in a method. It would just say, perhaps there's a method called render on the view, and it takes in view state. And then what I would do inside of that function would be fun render. The parameter would be view state. What I do there is say when view state, open curly brace, I say is initial state. I would then know that I need to render the initial state. I'd show the first name, the last name, etc. When it's the updated first name state, I know I need to update the first name and the text color. When perhaps it's one of the other ones, which is, the foobar one, which is an object that we were talking about, that one means that I perhaps need to update the background color to red or purple of the entire screen for whatever reason. But the nice thing about this is I come and I look at the function that's actually doing the rendering. So the render method that I've created in the view, I can just look at that when expression and say, hey, when it's the initial state, this is going to happen. When it's an update state, this is going to happen. When it's this is going to happen. And it makes it real easy for me to follow the logical flow of code. Super simple and makes it really, really easy. Now, a lot of times folks kind of look at sealed classes and think like, well, these kind of look like enums that I've used in Java or Kotlin or even any other language. So why would I use a sealed class? Now, the set of values for an enum type is also restricted, very similar to a sealed class. But here's the thing though. Each enum constant exists only as a single instance. So it's only around once. So if I have, the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, there's only a single instance of Monday. I can't have multiple instances of Monday. It's just Monday. It is what it is. Now, if we're a subclass of a sealed class, so the initial state, we could have multiple instances of that, which could contain different states. So I'm not actually limited to saying, hey, this is a kind of single instance of my initial state. Now, when would I do that? For this view example, probably wouldn't happen, but maybe I need to use this sealed class in a couple of different locations throughout my application. Perhaps I need to update. I have a status bar that I need to update somewhere that's built into my application on a tablet. And there's a status bar on the bottom and there's a status bar on the top and some type of data on the right-hand side. And all this data runs off of this sealed class. And one might show a extended kind of data. So it's like the long form. Another status bar might show a small version, and the one on the right-hand side might show just the abbreviations. And so I might need to have 3 instances of this initial state class, each going to take different values in it. So that allows us, sealed classes allow us to have multiple instances that can contain state, while an enum doesn't allow us to do that. So to recap, with sealed classes, you're going to create them with the sealed modifier. And you're going to type sealed class, the name of the sealed class. All of the type hierarchies must be defined within the same file. They can be data classes, they can be regular classes, they can be objects. If you plan to allow extension of these classes, of course, you're going to need to open them up with the open modifier. If you would like to extend one of these classes that are an inheritor from this sealed class, you can do that in the current file, or you could do that on another file. It just cannot be the actual sealed class itself. Sealed classes, of course, like we mentioned, are abstract already. They can't be instantiated. You cannot have any non-private constructors because their constructors are private by default. And you can use them with the when expression. This makes your code super readable and actually makes it quite fun to write. Now, again, if you're interested, there's of course, Google's at your fingertips. You can Google sealed classes and see all kinds of examples. If you want to see it in a real working project, you can check out the MVI course on caster.io. And of course, feel free to send us a comment here on fragmentedpodcast.com on our website, or hit us up on Twitter. Thanks for listening.
I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from waitlist recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.